Welcome to today's session on the top 10 LeetCode SQL Interview Questions that every data engineer and analyst should know. Here's the list. These problems are among the most frequently asked in interviews at big tech companies.
Hey everyone, and welcome to Data Copilot. Today, we're going to do something a little different. We're running a mock interview, basically a coaching session, to help you absolutely crush the top 10 SQL questions you're going to see in your next technical interview. So, I'll be playing the part of the interviewer, and I'll be your expert guide, breaking down the why behind each answer. Because the goal here is to get way beyond just memorizing code.
That's exactly right. We want you to really get the patterns, so you can handle any curveball an interviewer might throw your way. Yeah, think of this as your personal SQL workout before the big game. You ready? Let's jump right in. Okay, first up, we are tackling the absolute bread and butter of SQL, joining tables. You really can't build anything interesting without nailing this, so let's see how these first few questions test that core skill.
All right, first question for you. Imagine you have a person table and an address table. Your task is to report the first name, last name, city, and state for every single person. Now, here's the catch. If a person's address doesn't exist, they still need to be in the final report, just with null for the city and state. What's your move? Okay, so the magic words there are for every single person. That's the biggest clue you can get. It's screaming that we need to prioritize the person table, which immediately makes me think left join. So you start with from person, that's our left table, and you left join the address table to it. If there's a match on the ID, great, you get the address. But if there's no match, the left join is what guarantees that person still shows up in our results, just with null in those address columns. It's perfect for this scenario.
Okay, this next one, it's a rite of passage, a true classic. You've got one employee table. It has salaries, and it has a manager ID for each person. How do you find all the employees who earn more than their own managers? Ah, yes, the self-join question. This one definitely trips people up at first, but it's such a cool problem. The whole trick is to pretend the employee table is actually two different tables. You just give them aliases, right? So you'll have one called E for the employee and another one called M for the manager. Then you just join E to M, where the employee's manager ID is the same as the manager's ID. Once you've made that connection, it's a piece of cake. Just a simple where clause to see if E salary is greater than M.salary.
Okay, let's switch gears a bit. Instead of finding what's there, let's find what isn't. You've got a customers table and an orders table. How do you pull a list of all the customers who have never, ever placed an order? This is another spot where left join is the absolute hero. The game plan is simple. You start with customers and left join orders using their common ID. The key is that this keeps every customer in the results, whether they have an order or not. And then, here's the magic part. You add a where clause at the end that says where orders.id is null. That single line filters out everyone who did have an order, leaving you with exactly the list you want.
Awesome. Those join patterns are so important. But as we all know, real-world data is, well, it's messy. So for this next section, let's talk about data quality. Finding and dealing with duplicates is a huge part of the job, and these next couple of questions are all about that.
Okay, next up, you've got a person table, and you need to find all the duplicate emails. We're not deleting anything yet, just flagging them. What's your go-to play here? Oh yeah, for this, group by and having is the dynamic duo. It's a two-step process. First, you group by the email column. That basically puts all the identical emails into little buckets. Then you use having, which is kind of like a where clause but for groups, to check the size of those buckets. By saying having count star greater than 1, you're just telling SQL, hey, only show me the buckets that have more than one email in them. And just like that, you've got your duplicates.
Perfect. Now for the logical next step, how do you actually delete those duplicates? The rule is you need to keep the one with the lowest ID and get rid of the rest. Right. This is where it gets a little trickier, but it's a really clever use of, you guessed it, another self-join. You basically join the person table to itself. Let's call them P1 and P2. You join them on the email, so you're matching up all the duplicate rows, but here's the secret sauce. In your where clause, you add a condition, P1.id greater than P2.id. This tells the delete statement to remove the row from P1 only if it finds a row in P2 that has the same email but a smaller ID. It's a really smart way to protect the original record and delete all the copies.
Excellent. We are flying through these. So for our next set of questions, we're moving past the basics of joins and grouping and into some more advanced filtering. This is where you have to apply some really specific, sometimes tricky conditions to pull out just the right data. All right, let's talk about time series data. You have a weather table with dates and temperatures. How would you write a query to find all the dates where the temperature was hotter than it was the day before? This is such a cool problem, and it's another chance for the self-join to shine, but this time with the date twist. So you join the weather table to itself. The crucial part is the on condition. You need to connect each day's row with the row for the previous day. A function like datadiff is perfect for this. You can specify datadiff of w1.recordDate, w2.recordDate equals 1. Once you've paired up all the consecutive days like that, the where clause is super simple. You just check if today's temperature is higher than yesterday's.
Okay, this next one is a real test of attention to detail. In your customer table, find the names of every customer who was not referred by the customer with ID equals 2. It sounds easy, but is there a trap I should be worried about? Oh, there absolutely is a trap, and it's a classic, null values. Everyone's first thought is to just write where referee ID not equals 2. But that's wrong. It'll actually miss anyone who wasn't referred by anybody, the people with null in that column. See, in SQL's world, null doesn't equal 2, but it also doesn't not equal 2. It's just unknown. So to get it right, you have to be explicit and say where referee ID not equals 2 or referee ID is null. That covers every possible case.
All right, let's do a more straightforward filtering question. A country is considered big if it has an area over 3 million square kilometers, or if its population is over 25 million. How do you find all the big countries? Yeah, this one is a nice clean test of the OR operator. It's a great reminder that sometimes the simplest tool is the right one. Your where clause just needs to check for one condition or the other. If either is true, the country makes the list. Nice and simple. Okay, we're in the home stretch. For our final section, we're going to focus on aggregation. This is where we move beyond just fetching rows of data and start creating real insights. We're talking about things like finding the second highest salary or counting up students in a class. This is where SQL really starts to tell a story with the data.
All right, another interview Hall of Famer, write a query to find the second highest salary in the employee table. And what should your query return if there is no second highest salary? This is a great one, and there are a few ways to do it, but my favorite modern solution uses offset and limit. It's so clean. First, you get all the distinct salaries, so you're not tricked by ties, and you order them from highest to lowest. Then you use offset 1, which literally tells SQL to skip the first result, aka the highest salary. Right after that, you say limit 1, which means, okay, now just give me the next one. And boom, that's your second highest salary. Best of all, if there isn't one, the query just returns null, which is exactly what you want.
Okay, let's bring it home with our final question. You have a courses table that lists students and the classes they're in. How would you find all the classes that have at least 5 students enrolled? And look at that, we've come full circle, right back to our friends group by and having. It just goes to show how fundamental this pattern is. You group by the class name to get your student counts for each course. Then you slap a having clause on the end to filter those groups, saying having count student greater than or equal to 5. It's the perfect way to aggregate your data and then ask questions about those aggregates.
And that's a wrap. 10 questions covering 10 absolutely crucial concepts. We hit on all kinds of joins, we wrangled duplicates and nulls, and we used aggregation to pull out key insights. Seriously, if you can master these patterns, you're going to be in fantastic shape for any SQL interview. Couldn't have said it better. And remember, everyone, the code is just the final step. Understanding the why, the logic that gets you to that code, that's the real key. That's what interviewers are listening for. So as you go, just think to yourself, which one of these felt a little shaky? Whichever it is, start there. Just practice that one concept until it feels like breathing.
We really hope this little session helps you go in and just ace that next interview. For more deep dive